So welcome to the course of financial management, and our today's lecture is regarding the calculation or valuation of um YTM of a coupon bond. So let's move towards the contents of this lecture. In this lecture we would understand that what is current yield and how do we calculate it. Then we would understand how do we evaluate the or estimate the YTM of coupon bond. Previously we have discussed how to estimate the YTM of zero coupon bond and how to find the value of a zero coupon bond, and then we have also discussed how to find the value of or how to calculate the value of a coupon bond. In this lecture we will discuss how to find the YTM of a coupon bond, and there are two methods that we are going to cover in this lecture. First one is the trial and error method, and the second one is interpolation. So let's move to our topic. So we will start with an example. Previously we have discussed this lecture. We have covered EAR. Let's assume there is a bond that have quoted price of $1,080, and it has a face value of 1,000 and its annual coupon is $100. So if its face value is 1,000 and its annual coupon is 100, so 100 divided by 1,000, that would give us 10%. So the coupon rate is 10% and the maturity is 5 years. What is the current yield and what is yield to maturity? So before we discuss current yield, we are going to discuss the concept of yield to maturity. We already know what yield to maturity is and how to calculate the yield to maturity in case of a zero coupon bond. Let me take you back towards that slide. This was the slide where we calculated the yield to maturity of a zero coupon bond. Now we are going to calculate the yield to maturity, the same thing, the same concept, using the coupon bond. Okay, so if you have watched my video, or if we have discussed the concept of capital budgeting, in capital budgeting we discussed the concept of IRR, internal rate of return, and there are two methods to find the internal rate of return. That is the trial and error method and the interpolation method. The similar is the case with the YTM. To find the YTM, we have a trial and error method and we have the method of interpolation. So let's move towards the solution. First we will discuss the trial and error method, and then we would look to into the interpolation method. So what do we do in trial and error method? This is our formula to calculate the bond price. In this specific example, we have the value of C, which is 100. We do not know what is YTM. We know what is N. We know the face value and we know the price of bond. So the price of bond is 1,080. The N is 5, the face value is 1,000, the C is 100. We are left with this YTM. So in previous discussion of zero coupon bond, we could estimate that directly from the formula, but in this case, because there are more than one unknown variables, so you'd have to use some other method to estimate this YTM. So how would we do it? We would use a trial and error method, and what we will do is we would use one interest rate, one YTM. We would assume an YTM. We would use it and see if the answer comes out to be 1,080. If it doesn't, we would change the YTM, assume another YTM, and then recalculate the re-estimate the formula and see if it comes out to be 1080. So let me bring the solution. It would be more clear if we have the solution on board. So this is our example. Remember the bond price, the current bond price. Our formula to find the current price of the bond is equal to C into 1 minus 1 divided by YTM raised to power n divided by YTM, this whole plus 1000 divided by YTM raised to power n. This is our formula. Previously, when we were calculating price of the bond, we were provided with the YTM rate, the yield to maturity rate. In this specific example, we know what the price of the bond is, what the current price of the bond is. We know that. So this part is no more unknown. We have the value. What is unknown is the YTM part. So what do? We use the same formula. We input the values. So the current bond price is 1080. The interest amount is 100. We leave the YTM. Now what we would do is, in trial and error method, we would assume one value of YTM, any value of YTM. Say I have assumed 7%. We would put that assumed YTM value into the formula and see if the right side of the equation term is equal to the left side of the equation. And left side of the equation is what? It is 1080. So the answer should be 1080. If the answer is 1080, then we know that we have used the correct percentage of YTM. We have used the correct YTM. If it isn't equal to 1080, then we would have to use some other we would have to assume some other value of YTM. So now you get the idea why it is called trial and error method. We are trying one value of YTM, and if the answer isn't correct, if there is an error, we try another value of YTM. So what we did, the same values we have written here, we just input the YTM value, and the answer is 1122, which is greater than 1080. So the answer should have been 1080. We need the answer to be 1080. So that means the value of YTM that we have assumed is lower. So if we increase the denominator, this value would decrease, right? So that means, so next for the next calculation, which YTM value should we assume? Should it be 6%, 5%, 9%, 10%? We do not know the exact number, but we know that it should be greater than 7, because if we increase the denominator, this value would decrease, and we need to decrease this value that it becomes equal to 1080. So let's assume a YTM of 9%. So I have done the calculations, YTM of 9%. We simply input the value in this our new formula. Now the answer is 1068. Is it equal to our desired answer, 1080? It isn't. Is it greater than that? No, it is less than the desired answer. So that means the value of YTM that we have assumed, the denominator is greater. We need to reduce it. Maybe we reduce it to 8.5 or 8% or 7.5. We do not know. We would keep on trying till we get the answer of 1080, till the left hand side is equal to the right hand side. I haven't written anything on this left hand side, but we know that it's 1080. So let's try 8%, and I did the calculations and it turned out to be 1080. So now we know that if we use 8% YTM, our left hand side would be equal to right hand side. So that is our correct YTM. This is what the YTM would be for this question. So we have found the yield to maturity using the trial and error method. Next we are going to discuss the interpolation method. I will come back to yield, current yield or bond yields in a minute, but before that I should complete this interpolation method. So how do we use interpolation method? This is the second method. So there are two steps. First we find two different rates. One rate would be greater than our actual YTM, and the other rate would be less than our actual YTM. That means in one assumed value of YTM, the answer should be greater than 1080, and in another assumed value of YTM, the answer should be less than 1080. The second step would be to use this formula of interpolation and find an estimate of YTM. So let's move back to our example. Let me discuss the first step before we delve into the formula. So the first step would be, we use some percentage, say for example 7%, we find this value. This is greater than 1080. Now we need to use another percentage of, we need to assume another percentage where the answer would be less than 1080. We use 9%, the answer is less than 1080. So this step is somewhat similar to the trial and error method. But in trial and error method, we would keep on trying different values. We were lucky enough to find 8% in this example, but it wouldn't be the situation every time. So in trial and error method, the issue is that we would have to keep on trying different values of YTM. But in interpolation method, we just need two values of YTM, two assumed values of YTM. So we have got 7%, we have got 9%. In one case, the answer is greater than 1080. In another case, the answer is less than 1080. That's all what we need to use interpolation method. So let's get back to the slides and understand the second step. We are done with the first step. First step was to find two different rates. The second step is to use this formula. And let's understand this formula. IL stands for the discount rate that is lower than the investment YTM. This is somewhat confusing, but the simple answer is that, the simple understanding is that IL is the interest rate where the answer is greater than 1080. Where the answer is greater than the desired answer. So, or the lower discount rate. IH would be the higher discount rate. So in our previous example, IL would be 7% and IH would be 9%. This is the value where the answer was greater than 1080, and this is the value where the answer was less than 1080. Then the PVL, that is the present value at discount rate of IL. So what was the answer that we found when we used 7% IL, the value of IL? So the answer was, let me get it here, the answer was 1122. PV YTM, this is the present value of YTM and the discount rate equal to the investment or our desired answer. So this is 1080. The higher would be PV, higher would be the answer that we find using the higher interest rate. So let me bring the solution. Okay, this is the formula that I have exactly copied it from there. Okay, so the lower interest rate was 7%, the higher interest rate was 9%, so 7% IH plus 9% minus 7%. PVL is 1122 minus 1080, the current value or the value that would be the at the correct YTM. Then PVL is the answer that we got at lower interest rate, and PVH is the answer that we got at higher interest rate. So by simplifying this, we get an answer of 8%, which is exactly similar to the one that we found using the trial and error method. So why do we need interpolation? I have already mentioned that when we use trial and error method, we have to use multiple assumed value of YTM. We have to try different values. So in this specific example, we were lucky enough to get the correct YTM of 8% at our third trial, but that won't be the case in each example. So the interpolation is easy because we just need two values of we assumed values of YTM. But the issue with with interpolation is that it would give us an assumed value of the estimated value of YTM. So it isn't the exact value. It would depend how far apart or what is the range between our IH and IL. The higher the range, the lower would be the accuracy of the estimates. The lower the range, the higher would be the accuracy of the estimate, but it is an estimate. So we have used interpolation, we have used trial and error method. We are left with current yield. Now, what is yield to maturity? We know that it is when we buy the bond and hold it till maturity. That is yield to maturity. That is the interest, that is the return that we earn from the bond, from this our investment. But what if we needed to know our annual investment, or the investment that we are going to earn just by the coupon? So to find that, we use the current yield, and current yield is the bond's annual coupon divided by its market value. So the current yield only considers the coupon portion of the return. It doesn't consider the premium or discount that we have from the return we earn from this bond. So it only assumes the coupon value. So moving on, let me go through this example. You are looking at two identical bonds in every aspect, for their coupon and of course their price. So they are same bonds. Both bonds have 12 years maturity. First bond, which is bond A, has a 10% annual coupon rate. Its coupon rate is 10% and sells at this price with face value of 1000. The second bond is bond B, has a 12% of coupon, which is similar. What do you think it would sell for? Now, what do we need to find here? We need to find the true value or intrinsic value of the coupon bond. Okay, so first we need to understand what this question requires us to solve. It asks us that what do you think it would sell for? Now, which bond it is talking about? The selling price of bond A is already given, so it sells for 935. So the selling price of bond A is also already there. We do not need to calculate the selling price of bond A. The question is asking us to calculate the selling price of bond B. Now, how do we calculate the selling price, or basically the intrinsic value of the bond B? The formula would be this formula, the valuation formula for coupon bond, because this is a coupon bond, which is mentioned that bond B has a 12% annual coupon rate. How do we find? Now, starting with the C, what is C if we wanted to find the intrinsic value of bond B? C would be 120. How do we know that? Bond B has the coupon rate of 12%. And it is saying that both bonds are identical, they both are same. So everything would be same except for the coupon. So in case of bond A, the coupon rate is 10%. In case of bond B, the coupon rate is 12%. The rest of the items are similar. So if the rest of the items are similar, then we know that the face value would be 1000, and the C would be 1000 into 0.12. That would be 12 by 100. And this would give us 120. So we know C is 120. What about YTM? Okay, let's come to the YTM at the end. Let's first say what would be the N. N is already mentioned here, and it says that both have 12 years of maturity. So N is 12. What is face value? Face value is 1000. Again, N is 12. And what about this bond price? Because they are identical, the bond price is 935.08, right? So now we have the elements of this formula. The only thing that we are left with YTM. Okay, let's not consider this value. So we need to find the intrinsic value of bond B, and for that we have all the elements except for the YTM. So if we somehow get the YTM, then we would be able to calculate the selling price or the intrinsic value of bond B. Now, how do we get the YTM? We need to follow, so how do we get the selling price of this bond? We need to follow the two-step procedure. In first step, what we are going to do is, if both bonds are similar in all aspect, then we need to first find the YTM of bond A. So we find the YTM of bond A. Then what do we do is we put that YTM in the previous formula, the YTM found in the first step, in the previous formula, to find the intrinsic value of the bond. Okay, now what we need to do is, we do know the formula of YTM, whether we use the trial and error method or we use the interpolation. What we need to do is we need to find the YTM of bond A, right? This is the first step. So to find the YTM of bond A, we have the left side of the equation. If we are following the trial and error method, we have the left side of the equation. We would first try, say, 10% interest rate, then we might increase or decrease the interest rate. We would get the YTM using, let's say, trial and error method. Once we have the YTM, then for the second stage, for the second step, when we are finding the selling price of this bond B, then what we would do is we would put that YTM in this formula. The rest values are already I have discussed, that C is 120 and N is 12, face value is 1000, and we would have this selling price of bond B. So I'm not going to solve this one. I suggest that you people try it yourself.